Tomorrow you will get the time. Okay. Logic gate, you will it will take the less time, maybe most of you, and all notes I will send today. 9:20 up to the 9:20. Okay, 9:20 I will try to complete the whole this full wave half wave rectifier. Okay, and second thing what I'm saying, I will send the whole notes. Maybe I will try. After that I will go for a study hour. Then I will take the picture. I will send the whole notes. Okay, revise the all gate formula, everything whatever will be in the notes. It is a responsibility of everyone. You will revise the formula properly. Okay, so then I can go fast in the tomorrow. Okay. Now nobody is taking offline now, only except me. Nobody is taking offline. All are going from the studio, but I am taking offline separately for all batches. I will send whole notes again. Okay. So in the night when you will get the notes, anybody will send the confirmations that we got the notes in the app. I will at 9:20 around I will go for the study hour. Then I will. Okay. Now I am starting the half wave rectifier. So first, okay, so diode as a rectifier. Okay, so I will send diode as rectifier. So what is a rectification process? Rectification is not converting AC into DC. That process is called the rectification. And the which device we are using, that is called the rectifier. Okay, so what is a rectifier? Rectifier converting AC into that process is called rectification. And what we are using, that which device we are using, that is called the rectifier. Okay, already done. This means half wave done. Okay, good. That part done. Very good. Then okay, so question I have discussed, like in the half wave rectifier, question how they can ask. Suppose I am saying so what will be the output? Output will be what? Like this. Means only positive cycle we will get output. Okay. And one more thing, that is your responsibility. I don't know the Satadal sir has said or not in the AC that all AC is in the, they have given in the NCRT all sinusoidal. So sinusoidal, when it is a half wave, then what is a half wave? What is the average value for the half wave? What is the DC output? All these you have to relate with the what? AC alternating current. I think he has said. So here I am giving what? Half wave. This is the input alternating voltage. Input more alternating means this is a positive cycle, negative cycle, positive cycle, negative cycle, like that it is there. Okay, and it passed from the half wave rectifier circuit. Then what will be there? Only half wave will get positive, half will get rectified. Then you will get the positive cycle only. If they are saying the diode reverse, if the diode is reverse, then what will be the output? Then negative cycle you will get as a output. This everybody got, because half wave rectifier I said positive cycle we will get as a output. Now suppose we are reversing the what? Diode. Then what will happen? Output will also get reversed. So if we are reversing the diode, then we will get the negative cycle as output. Okay. Understood or not? Okay. Suppose this is the input I have given, sinusoidal alternating voltage. I am asking what is the which cycle, what we will get the output. Positive cycle we will get as the output, negative cycle we will get the output. So listen here. In the what diagram I used to explain the half wave rectifier, I connected the diode here. I connected the diode here. So what the current diode was getting, in what the figure I made to explain, what current diode was getting, the same current load was getting. That's why in that case we got the positive cycle as an output. What I use in that, if you remember, I connect the diode here and I connect the load here. So which cycle diode was getting, the same cycle load was getting. But here, that is here I am using the diode with the load, parallel with the load. Okay, one thing. Second thing, what, when they will not say this is the rectifier circuit, we have to know what, when they are using the input alternating voltage or current, and they are using the one diode. It means it is a rectifier, half wave rectifier circuit. Maybe they will not say it is a rectifier circuit. You have to know input they are giving what, alternating, and one diode they have given, and they are connected the load. So it means it is a half wave rectifier circuit. Now we have to decide what it is. It will give the positive cycle output or it will give the negative cycle output. So what figure I made for the explanation, in that case we got the positive cycle as the output. But here what will happen, diode and load are connected in parallel. Okay, so it's like positive cycle, this will be positive, this will be negative. When this is positive, then diode will be in the forward bias. Okay, what I said the same. When it is a positive, it is a negative, so diode is in the forward bias. When diode is in the forward bias, then current will, like here positive, here negative, so current will get conduct here. Okay, for positive cycle, diode is in the forward bias. When diode is in the forward bias, we know that current always flow from minimum resistance path. So when current is coming here, it has the two paths, one this and one this. And in that, diode is in the forward bias, so diode will offer the zero resistance. So basically that path is a conducting path. So what will happen, load will not get the current. For the positive cycle, this diode will be in the forward bias. So when the current is coming, current has the two paths, one this. So it will flow from the minimum resistance path or zero resistance path. So, and diode is giving the zero resistance path. So means this load will get shorted. Okay. So what will happen? Positive cycle diode will pass from the diode like this. Positive cycle will pass from the diode. Load will not get the positive cycle. Okay. Why? They connected in parallel. So what cycle diode will get, that cycle load will not get. Earlier what I explained, in that I connected in series. What cycle diode was getting, the same cycle output got. So here diode got the positive cycle, load didn't get the positive cycle. Now for negative cycle, what will happen? Diode will be in the reverse bias. Reverse bias, it will offer the infinite resistance. Then what will happen? When it will offer infinite resistance, so this branch will behave like an open branch. So current will directly go to the load. So which current we will get in the load? For which cycle we will get in the load? Negative cycle. Everybody understood or not? So in that case, what is the output? Like that way you will get. Everybody understood or not? Okay. So efficiency formula they have not given in the NCERT also, what is the efficiency of the half wave rectifier, full wave rectifier. But if you have the module, some test you are solving, in that they are using the efficiency formula. But that is optional. I'm just writing here. Okay. What I'm saying here, diode, positive cycle diode is in the forward bias. So current always flow from minimum resistance path or zero resistance path. So here it is going here. Now positive and negative, the diode is in the forward bias and resistance of the diode in forward bias is zero. So this load will get shorted. So that's why current will directly go from here to here. Load will not get the positive cycle. So load will get which cycle? It will get the negative cycle. That's why output will be negative cycle. Voltage, why the voltage will divide? It is a parallel combination. Na? Diode and the load is a parallel combination. So why voltage will get divided? Completed? Now full wave rectifier. Now listen here. So this is the full wave rectifier circuit. Okay, so for the full wave rectifier circuit, we are using the here two diode. Okay, and this is the this symbol everybody know. This is the primary winding of the transformer. This is the secondary coil of the transformer. This is called the center tap transformer. What is the meaning of center tapping? First, listen. Here I have the two diode. Here I have two diode, but we are applying the one input signal. But I have the two diodes, so we need the two input. We need the two input, one for the D1, one for the D2. Okay. So here what we are doing the center tapping. Tap means touching. You know that tap when we are tapping someone. So tap means what? Touching. Okay. So we are touching, we are putting one contact. We are putting one contact at secondary coil. We are putting one contact at secondary coil and we are putting that contact at the center. That's why it is called the center tap. Center tapping means we are putting one contact at the midpoint of the secondary coil. At the midpoint of the secondary coil. And that contact we are connecting with the earth. That is the earthing. Okay, so means potential of that point is 0. So what is the meaning of center tap? Center tap means we are dividing the secondary winding into the two equal part. Because we are doing the center tapping. So we are dividing secondary winding into the two equal part. So suppose secondary winding has 1,000 number of turn. Transformer, I think everybody know. Suppose secondary winding has 1,000 number of turn. So center tapping will divide the whole turn into the 500 and 500. Why we are doing the center tapping? Because we have the two diode, D1 and D2. So input we want both, two input we want, one for the D1, one for the D2. But one AC signal we are applying. So that's why we are doing the center tapping. Now you can understand, suppose we are giving the positive cycle. So positive cycle means here positive, here negative. Okay. By doing the center tapping, here potential 0 will develop. Okay. So now you can see, suppose here V, here 0. So potential difference between these two is what? V. And who is at higher potential? D1. This point is at higher potential. If you see the below one is what? This is the minus V, this is the 0. So who is getting negative? D2 is getting negative. So by this way, we are getting the output in the transformer. Output in the transformer is what? N2 into d5 by dt. N2 into d5 by dt. That is the output of the transformer. Now that N2 I divide into the two part. So N2 by 2 d5 by dt. N2 by 2 d5 by dt. So that upward D1 is getting 1, D2 is getting. But D1 is getting the positive, then D2 is getting negative. This everybody got or not? What is the meaning of center tapping? Means input we are dividing into the two equal part. So D1 will get positive, so D2 will get negative. So input of D1 I can make, suppose input of D1 is getting positive cycle, then negative cycle like that. Then input of D2 what you will get? This everybody understood or not? If D1 will get positive cycle, If D1 will get positive cycle, then D2 will get negative cycle. So at t is equal to 0, D1 is getting positive and D2 is getting negative, but their magnitude will be equal. That because we are doing the center tapping. Center tapping means N2 by 2 for above, N2 by 2 for below. Okay, up to this okay. Now at t is equal to 0, D1 will get positive cycle, D1 will get positive cycle, D2 will get negative cycle. When it is a positive, then D1 is in the forward bias. When it is a negative, it is getting negative, then D2 will be in the reverse bias. So how the current will flow? D1 is the forward bias, so current will conduct from here, and then load will get the current from A to B. Load will get current from A to B. And that current you got due to the D1, that current you got to the D1. So first half for the D1 positive, D2 negative. That's why current conducted by D1. So in the load we got the current from A to B. Now after the next cycle, what will happen? D1 will get negative cycle, then D2 will get positive cycle. When D1 got the negative cycle, D2 got the positive cycle, then what will happen? D1 is in the reverse bias, D2 is in the forward bias. When D2 is the forward bias, current will go from here. Again, current will flow from A to B. So now second cycle, second half, the current flows due to the D2. And we can see here, current we are getting in the load from A to B. Current in the load we are getting from A to B. For both cycle, B to A. Srisha, how? Current is going from D2, then here, and then in the load you will get from A to B only. Due to the D1 here and then A to B. Okay. Now due to the D2, current will go from here, but in the load where you will get A to B. So both cycle current you will get from A to B or not? Are say fast. Both cycle current you will get from A to B or not? Both cycle current you will get from A to B or not? Everybody. So first cycle you got due to the D1, second cycle you got due to the D2, but for the both cycle we are getting the current from A to B. It means both cycle get rectified. Both cycle. In the previous case what was happening? We were getting the current in one and then after that no current was there. So only half wave get rectified. But here what is happening? We are getting the current in a load for both. First one due to the D1, second we are getting due to the D2. So what is the output here? This is due to the D1, this is due to the D2, then again D1, then again D2, like that you will get. Understood or not? What is not center tap? That how you will get the input together in a D1 and D2? Jonathan, if it is not the center tap, how you will get the input together in a D1 and D2? Because we need the two input here because two diodes are there. Without the center tap, we are using the bridge rectifier. Next I will say bridge rectifier. Without the center tapping, we are using the bridge rectifier. In that, we will not use transformer. I will say later. So this everybody got. Now I think everybody know what is the average value of the D. In that case, we are getting the DC. What is the average value of DC in a half cycle? Average value is the 2 V naught by pi. What is the RMS value? V naught by root 2. So in that case, DC average value, RMS value, we have to remember. In the half cycle, maybe sir said in the AC half cycle, if they are asking. Because basically what was there in a half wave rectifier? One cycle was what? Cycle and no cycle. What was the one cycle there in the case of half? Cycle and no cycle. So in that case, one cycle was what? Cycle and no cycle. So in that case, average will come V naught by pi. Average will come V naught by pi. Why? 2 V naught by pi and 0. Then average will come V naught by pi. And remember that RMS value will come V naught by 2. I can show by the mathematics, but maybe sir has said. Average value of the RMS value in the half wave you will get V naught by 2. Full wave V naught by root 2. That what you marked up. Okay, but for the half wave, you will get the V naught by 2. V naught by 2, because what is happening there? Cycle and no cycle. Then after taking the mean square and when you will take the root, you will get the V naught by 2. I think Satadhar sir said. So half wave rectifier average value for the one cycle is what? V naught by pi. Why? Cycle and no cycle is there. What is the RMS value for the cycle? V naught by 2. But here, what is the average value? 2 V naught by pi. And what is the RMS value? V naught by root 2. Here, everybody know. There half wave, only the problem is there. Okay. So you will get the notes in that I have said in the class. So that will be written there. Okay, you can revise. What is the average value for the half wave? What is the RMS value for the half wave? Okay. Now listen. Here in this output, two problems are there. In this output, two problems are there. What is the one? Most of the time DC, just now Akhilesh sir also discussed DC. When we are saying that DC, we are taking a magnitude constant like 10 volt battery, 5 volt battery, current we are saying 2 ampere, 3 ampere, means current or voltage is constant. Okay, that mainly we are using the constant DC. We are using the constant DC. Okay. But here what is happening? We are getting the DC. Why DC? Because it is flowing in the one direction. The current in the load we are getting from A to B. Current in the load we are getting from A to B. Okay. But what is the problem here? So direction, that is the same. So direction is same. So that's why it is DC. But here what is happening? Magnitude of voltage is changing with time. Going up, down. Means here variation are there in the magnitude. Most of the like what the DC we have learned in the battery or cell, their potential is constant, like 5 volt. So 5 volt cell I have. So 5 volt is constant. 10 volt battery I have. That 10 volt is constant. But here in the DC alternating voltage, the direct voltage, what we are getting? Magnitude is changing with time, going up, down, like that it is happening. So this is called the pulsating DC. This is called pulsating DC, like pulse, going up, down. So here DC magnitude is in full wave rectifier. What the DC we are getting, that DC magnitude is not constant. So this is called the pulsating DC. This everybody got. So that is the one problem. Here magnitude is not constant. Okay, that is called the pulsating DC. Second thing, we know that in reverse bias for ideal diode, it will offer the infinite resistance. So current will be 0. But nothing is ideal. So what will happen? We have learned in the reverse biasing and forward biasing. In the reverse bias, diode conduct very small current, that is the order of the microampere. So when the D1 is in the forward bias, then D2 is in the reverse bias. When D2 is in the reverse bias, so D2 will conduct very small current, but it will conduct because nothing is ideal. So in the reverse bias also, we will get the current. Due to that, like D1 is in forward, so D2 is in the reverse. So if the D1 current is going from A to B, so D2 current will go from B to A. So what will happen in this center tapping transformer, in this combination, we will get some AC components also there. In this DC, some AC component is also there because reverse bias current will not be 0. Very small current will be there, but it will be there. So that's why some AC component will be there in this DC. That AC component is called ripples. This everybody got. What is the meaning of pulsating? Pulsating means here magnitudes are going up and down. Magnitude is not constant. So that is a pulsating DC. Second thing is what? In that case, some AC component also we are getting due to the what? In the reverse biasing, current will not be 0. Current will be small, but it will be there. That's why that AC component in the DC is called ripples. Up to this, okay? This magnitude of DC is not constant. That for this we are calling the name pulsating DC. Okay, pulses are there, up down. Okay. Second thing, in the reverse bias, like D1 is in the forward, so I am getting the current due to the D1 from A to B. But in the D2 will be in reverse bias. in D2 in the reverse bias, so in reverse bias current will not be zero because the diode we are considering in the numerical diode is ideal, but practically diode is not ideal. So in the reverse bias it will have some current. So we will get the some AC component also in this rectifier, and that AC component are called ripples. Okay. So to remove the ripples and make get the constant DC, we are using the filter circuit. To remove the ripples. To remove the ripples, we are using the filter circuit. That filter circuit can contain either the capacitor. So when it is a capacitor filter, then capacitor you will connect in parallel. I'm not writing anything. You will get the notes in that all thing has written. What I'm saying, when I'm using the capacitor, that capacitor filter will connect in the parallel with the load. Parallel with the load means where I'm getting the DC, load I'm getting the output. So load I'm getting DC. So that capacitor I will connect in parallel with the load in the filter circuit. Okay. Otherwise, we can use the inductor. If we are using the inductor, so that inductor we will connect in series with the load. So in filter, we can either use the capacitor, and then capacitor filter we have to connect in parallel with the load. And we can use either the inductor, that inductor filter we will connect in series with the load. Easy way we can understand why we are using this. So just imagine like suppose you have the constant DC. So constant DC means frequency is zero. That maybe you have learned in the alternating current. Constant DC, frequency is zero. Okay. So when the frequency is zero, then capacitive reactance Xc is equal to 1 upon 2 pi Fc. Okay. When frequency is zero, DC frequency is zero, capacitive reactance will be infinite. Okay. It means we can say like constant DC. When it is a DC, then capacitor will offer the large reactance. So it will not allow the DC to flow through this. So means DC will not go to the capacitor. But for AC frequencies are there, and we will take the large capacitor. Capacitance. So C is large, frequency is there, then 1 upon 2 pi Fc. F is there, C is large, so reactance will be small. So capacitor will have the small reactance for the large, when it has a large capacitance and it is a AC, so its reactance will be small. When its reactance will be small, then it will allow the AC. So when the combination of AC and DC means that DC with ripples are going. So what the filter capacitor will do, AC component it will take, and it will send the DC component to the load. So what will happen, that AC ripples get filtered out. This everybody got or not? So in the filter we can use the capacitor. That capacitor we can have to connect in parallel. So that capacitor will do what? It will take the AC component, it will take the ripples, and the DC pure DC it will send to the load. Okay. Second, suppose we are connecting the inductor in series. So inductive reactance is what? 2 pi FL. Inductive reactance is the 2 pi FL. So when the DC, suppose I am using the constant DC, or DC frequency will be small in that case. So DC frequency is there. So DC frequency, then inductive reactance will be what? 0 for the DC. So it will allow the DC to flow through this, and it will offer large reactance for the AC. So when I am using the inductor in series, so it will allow the DC flow through this. So DC will flow through the inductor, and inductor is connected in series with the load. So the inductor and the load will get the DC, and the AC will get filtered out. The ripples will get filtered out. That's why we are connecting in capacitor in parallel, or we are connecting inductor in series. That is a filtration or filter circuit. Okay. Last year this question also they asked in center tap transformer capacitor diode filter circuit. We are using the filter. We are using which component as a filter to remove the ripples. Capacitor, diode, like that option they are given. So what we use as a filter in the to remove the ripples, capacitor. Understood or not? So all this discussion, what I said, that is written in the notes as a note. I said in the class. I will send the note. You can read. Okay. This completed. Okay. And frequency relation, everything you can get from here. Like here, frequency of input. Frequency of input, if I am taking F, frequency of input is F, then here what will happen? Here time period is this, here time period is this, because after this it is repeating. So here time period got half, so frequency will become double. So what is the frequency output here? 2F. So in the case of half wave rectifier, in the half wave rectifier, frequency of input and frequency of output was same. But in the case of full wave rectifier, frequency of input and is F, then frequency of output will be double. Why? Basically time period become half. Time period means the time after which they will repeat. So they are repeating now after half time. So that's why time period become half, so frequency will get double. Okay. Completed. Now bridge rectifier. Bridge rectifier, what I'm saying, in the NCERT, in bracket they have written, without using center tapping we can get the full wave rectification, but they have not used the name bridge rectifier and they have not given this circuit also. But in the bracket, in the center tapping, they are saying without using center tapping we can get the full wave rectifier. That is called the bridge rectifier. Okay, so bridge rectifier, how we will use in the bridge rectifier, 4 diodes we will use. First I am making the circuit, then after that I will explain. Okay, so this is a full that is a bridge rectifier circuit. Bridge rectifier, how many diodes we are using? 4 diodes we are using. How you can remember the, like it is like a weight stone, but how we can you can remember how we have connected the diode. So just remember, if you see all the 4 diodes, all the arrows are up, all the arrows are up, you can see this is up, this is up, this is up, this is up. Okay, so 2 diode up, 2 diode down, and all the diodes arrow will be up. That like that way you can remember. Okay. Naming they can give according to them, so you have to understand how the currents are flowing, which will be in the reverse bias. So we cannot directly remember this is the order they will give, whatever the name they are giving, according to that we have to follow. Okay, so here this is the full wave rectifier bridge circuit. Now in that case what will happen? Suppose alternating voltage we are applying. So first positive cycle, this is positive, this is negative. So when this is positive, you can see D1 is in the forward bias, D2 is in the reverse bias. Okay, and here it is negative and negative means D3 negative, N is connected with negative. It means here N is at lower. So this D3 will be in forward bias, this D2 will be in the reverse bias. So positive half cycle, you can see this is the forward bias, this is the reverse bias, this is the reverse bias, this is the forward bias. Okay, then now how the current will flow? So positive cycle current will go from here, D1 is in the forwards, it will conduct the current, then in this I got the current from A to B, current will go from A to B, then here, then again D3 is in the forward bias, the current will go to the D3 here, then it will come to back to the negative. Okay, so current flows from the resistor from A to B, yes or no? And first cycle flow due to the D1 and D3. So we got the first cycle due to the D1 and D3. Okay, this everybody understood or not? Okay, now next cycle what will happen? When this will become negative, this will become positive. Okay, polarity will get reversed, so this will become positive, this will become negative. So when this is a positive, then you can see D2 will be in the forward bias, D3 will be in the reverse bias. Okay, here it is a negative, so D4 is in the forward bias and D1 is in the reverse bias. Okay, now you can see this terminal is next half cycle, this will be positive, then current will go from here. Current will go from here, D2 is in the forward bias, D2 is in the forward bias, then load current A to B, then D4 is in the forward bias, current will go from here to here, then again come back. Then also A to B or not. But here it is flowing due to the D2 and D4. Next half cycle, negative half cycle, we are getting due to the D2 and D4. So current is flowing in a one direction. So full wave get rectified or not? Completed? Okay, so 3 optoelectronic devices are remaining. Okay, that is okay now. It is completed now. Like that way, then again D1 to D3, then again D2 D4. Like that way, you will get the cycle. Okay. AC, how like AC? This is the AC source, alternating source we have connected now. Okay, so 3 like photodiode, solar cell, and the LED that is remaining. After that, logic gate. So today I will send the notes. I'm going to the our study hour. I will send the notes. Okay, and then you have to what? You have to read all logic gates, all the formula you will learn. That's why then I can complete fast, and then I will say what the timetable they have to make. Okay, and then you will get the information. Today it is become late because I came early, but class was going. I thought otherwise I will take up to the. That's why I took put the time 7:30. Yeah, morning I will take. I will take in the morning. I will see. Okay, because there are some syllabus is remaining. So I will send the note. I will try if I'm going and in the campus. I will take the picture. I will send the notes. Please read the all points of the all formula of the logic gate. Okay, all points of the photodiode is there. I will explain all here. Okay. Okay, then bye bye. Take rest. Good night. Okay. Yeah, I will give. No problem. I'm going there.